switch away from looking at absolute value equations, and let's talk about what happens when we have an absolute value that is in part of an inequality. First, let's just picture what's going on, because I think it's kind of easy to think graphically about this. We know absolute value means our distance from 0 to a number. So we know that the absolute value of some number is 7. Well, there's two possible answers, right? We know that the numbers that could satisfy that situation are 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, -7. Both of those numbers, that distance and this distance, those are both 7 away from 0. So I know that these two numbers are my boundary points. Remember, with boundary points, we have greater than or equal to, so we're going to use closed dots. So I know I have a closed dot here at 7 and another one at -7. Now the question is, if I'm saying that my distance from 0, that's what absolute value means, my distance from 0 has to be less than 7. Well, what are my possible solutions? Would 8 be a possible solution? No, it wouldn't. All my possible solutions are right here. Right? Let me actually make that pink. These are the possible solutions. These are the numbers where my distance from 0 would be less than or equal to 7. So you could test out a few numbers if you wanted. Like if I chose the number 1, is the distance from 1 to 0 less than 7? Yeah, it is. That would fit. What about the distance of -1? If I chose a -1 for f, if x equals -1, well, what's the absolute value of -1? That just equals 1. Is 1 less than 7? Yes. So any number that I choose between these 2 points will give me a solution to this inequality. So this is my solution set right here. We could think about this like an and compound inequality, right? I know that the x has to be less than or equal to 7, right? That's how far I am away from there. But I also know that as long as my values are bigger than -7, that I'm also within the range of being a distance of less than 7 away from 0. Okay, so this is like an and problem. Over here, well, let me give you a little bit more explanation, because notice that I flipped the sign right here, right? This is like if I were to write it separately, it would say x is less than or equal to 7, and this one is x is greater than or equal to -7. Well, why did I do that? Remember that when we were solving equations, we would set up two different equations, because we didn't know if the number in here was positive to begin with to get us an absolute value of +7, or if it was negative. So I could do these two things. I could say the positive x is less than 7, and I know that negative x is also less than or equal to 7, like if this were a negative number inside there. So then I would have to solve for x on this case, I'd multiply by -1. And remember, whenever we multiply or divide by negative, we have to flip our sign. So I end up with x greater than or equal to -7. So that's why I flipped the sign on that one. That's how come I can write this as an and problem. So whenever you have an absolute value that starts out with a less than it's going to be like an and problem. You're going to have less than this one and greater than that one. That means your answers will be between those two boundary points. But let's look and see what happens if we have x being greater than or equal to 7. Well, let's just think about on the graph again, because I think conceptually we can kind of see this without doing any math. Right? So if I'm here at 0, and I'm saying, here's my boundary point at 7. If I'm saying that absolute value of x, so the distance from x is more than 7. Well, what are numbers that are more than 7? 8, 9, 10, all these ones, right? Right? But what other numbers could I plug in for x that would still give me the absolute value that is greater than 7? Well, if I plug in -7, that would be equal to 7. So you can see the color. What if I plugged in -8? That would have a distance from 0 of bigger than 7, right? Or 9 or 10. So notice that if the absolute value is greater than 7, then I end up with what looks like an OR problem. One of those OR inequalities that we were working on yesterday. For example, I could write this as two separate things. I could say that x is greater than or equal to 7, or x is less than or equal to -7, because those were the values that would make an absolute value greater than 7. Okay? So let's look at how we're going to use these. Let's look if we can solve some equations. Here we have an absolute value all by itself inside, or a variable all by itself inside the absolute value. So I'm going to just get that term by itself. I'm going to subtract 2 from both sides, and I get absolute value of x less than 5. Well, how can I think about where is the absolute value going to be less than 5? So that means the distance from 0 has to be 1, 2, 3, 4, 5. Less than 5. It can't be at 5 because it's not inclusive. Any number that I choose in here will have a distance less than 5 from 0. And any number I choose in here has a distance less than 5, right? This has a distance less than 5. This has a distance less than 5. So the set of all the numbers that have an absolute value less than 5 would be -5 less than x, which is less than +5. My answers have to be in between those two numbers. Right? This second example, again, it's slightly more complicated because I have something inside my absolute value with the x. So I have to make two separate inequalities. I have to say, well, these numbers inside here, they could add up to a negative and take the absolute value and you'll get +7. Or they could add up to a positive, take the absolute value, and it's still positive. So I'm going to set up two separate absolute inequality to solve. I'm going to set up x plus 2 is greater than or equal to 7, or x plus 2 is less than or equal to -7. Notice that when I do the opposite of the number, like if I use this opposite, I have to use the opposite sign as well. I have to flip my sign. So then I will solve separately these two inequalities. Subtract 2. So x is greater than or equal to 5, or, why did I subtract 7? Subtract 2. X is less than or equal to -9. So if I were to graph that, I would say, well, here's 5. X has to be bigger than that, or X has to be less than 9. And let's plug in some values and make sure that that makes sense. Like, let's say I chose -10. If I put -10 in here, -10 plus 2, that gives me the absolute value of -8, which is just 8. Is 8 greater than 7? Yes, it is. So yes, that is an answer. Let's check over here. Let's plug in 6. If I say the absolute value of 6 plus 2, well, that's 8. The absolute value of 8 is 8, which is also greater than or equal to 7. So, check. That answer works as well. I could also just plug something in the middle. If I plugged in 0, and I said 0 plus 2, that gives me the absolute value of 2. Is 2 greater than or equal to 7? No, it isn't. So that I know can't be a solution. So all the solutions that would make this true are from 5 up or from -9 down. Let's work out one more, and then I'll give you a minute to try it on your own. Again, I have more than one term inside the absolute value. So I'm going to set up 2 totally separate equations. I'm going to do 2x minus, this is meant to be, that's meant to be greater than or equal to. 2x minus 3 greater than or equal to 1, or 2x minus 3 less than or equal to -1. Remember, I do the opposite of this, so I have to do the opposite of that. That's where I'm getting those -1 and less than or equal to. Now I just am going to solve like I normally would. 2x greater than or equal to 4 divided by 2, and I get x greater than or equal to 2. Over here, add 3. 2x less than or equal to 2 by 2, x less than or equal to 1. So my range of solutions is the x has to either be bigger than 2, or it has to be less than 1. Okay, go ahead and pause the video and try these 2 problems on your own and see how you do. For each of these, we are going to have to set up 2 separate inequalities. 3x minus 6 greater than or equal to 9, or 3x minus 6 less than or equal to -9. And now I'm just going to solve. 6 plus 6, 3x greater than or equal to 15, and x is greater than or equal to 5. On this one, 3x less than or equal to -3, and x is less than or equal to -1. So if I were to graph the possible solutions of this, I would say the x has to be bigger than or equal to 5, or it has to be less than or equal to -1. Those are all the possible solutions for that absolute value inequality. For number 8, we do the same thing. We say 4x minus 12 less than or equal to 20, and 4x minus 12 greater than or equal to -20. Notice this one, that one is a greater than, so we expect to have an or situation. We expect to have a blank in the middle and the answers going on either side. With the less than, we expect this to look like an and problem. So our solution should be bigger, should be bounded by, well, let's find our boundary points first, and then we'll see. So I have 12, so I get 4x less than or equal to 32, divide 4, so x is less than or equal to 8. Over here, 4x greater than or equal to, that's negative 8, divide 4, x is greater than or equal to negative 2. So I expect my answers to be between my two boundary points. So here's negative 2, and here's 8. This is filled in circle because of the greater than or equal to. So all the answers here have to be greater than negative 2, and they have to be less than negative 8. So my set of all solutions would be from negative 2 to negative 8. If I were writing that in an interval, I'd say go from negative 2 to positive 8, and I'm using brackets because it's inclusive. If I were going to write this one is a little trickier for an interval. I'm going to start, it would start at negative infinity, and then it would go up to 1. And then I would start again at 5 and keep going to positive infinity. All right, one last problem. This one is going to work out just the same. We're going to do the same thing, but before we start, we've got to get this absolute value term so that it's all by itself, so that we can set up the two different equations, or I guess this is supposed to be an inequality. I'm going to divide both sides by 3 to begin with, because this is multiplying. You can kind of think of these absolute value bars almost like parentheses that you could distribute through, but I think it will be easier if I just cancel those 3's from the beginning and say I've got the absolute value of 2x minus 3 greater than or equal to 1. Now it's just like those other two problems we just did, and we're going to create two different inequalities. One of them will be 2x minus 3 greater than or equal to 1, and the other one, 2x minus 3 less than or equal to negative 1. Add 3. 2x is greater than or equal to 4, or x greater than or equal to 2, and over here, 2x less than or equal to, that's 2, x less than or equal to 1. So if I graph my answer, I've got x has to be less than or equal to 1. Oh, I didn't draw that very centered, did I? Let me try that again. My lower bound is 1, and every number less than that. And then my upper bound is 2, and every number bigger than that. Okay, so my interval would be from I wrote an 8. Okay, from negative infinity up to positive 1, and 2 up to infinity.